Here is a speed run of the force extension required practical. Thank you for the request. Pay close attention because after all this research to make our predicted papers, I am expecting and predicting that this will be one of the practicals on physics this year. Sweet, okay, start with the purpose. We need to see how the force on a spring affects its extension. So we change the force by using these masses here. Every 100 gram mass is the same as 1 Newton of force. And remember, we change that force on the spring to see how it affects its extension. So measuring extension is the next job. And you get that by finding the change in the length. That's what extension is. So you measure the starting length and then the end length and find the difference to get your extension. And you do that with a ruler. It would be wise to also mention that we repeat this for every single force that we have so that we can calculate a mean and discount any anomalous results. Get more accurate answers that way too. Great, so when you have readings of extension for a variety of forces, you can go and plot this graph of force against extension. You'll notice that along this point here, we have direct proportion because it's a straight line that goes through the origin. You should always see that. That's because Hooke's law states that the extension of an object is directly proportional to the force that causes it. And that's what you see here with a straight line through the origin up to this point here where it starts to curve. We call this point here the limit of proportionality because after that point, if you add more forces, we see an abnormal extra amount of extension. It curves up. This limit of proportionality could also be known as the elastic limit because before that, when you remove the force on your spring, it will return to its original shape. That's what elastic deformation is. But past that point, you will notice that the object would not return back to its original shape. So it's like when you overextend the spring and it doesn't go all the way back in again. We can call that inelastic deformation or plastic deformation. They both mean the same thing. Something to consider. They could ask you in this practical to find the spring constant from the graph. To do that, find the gradient of this part of the line and the spring constant would be 1 over that gradient. They quite often ask about safety with this practical too because how easy it is to drop things or get pinged in the eye by some sharp springs. So just say wear goggles. Also, you could clamp this to the table so it doesn't fall over. And lastly, parallax error, where you're reading from not eye level basically. So here my reading would look too small and down here my reading would look too big. We need to make sure that we read from eye level so that we avoid that parallax error, which would be a systematic error causing all of your results to shift. That's everything they could throw at you for that practical. We've smashed through that. If there's any other topics you'd like to look at, pop a request in the comments, send me a DM. And if you haven't yet checked out our predicted papers, head over to Chris Tuition and check them out. You will not regret it. Have a good evening.